Hello everyone, myself Ashwin V. S. Deva, currently pursuing BTech in Artificial Intelligence and Machine Learning in GM University. Today I am here to explain my assignment 1 of the subject Artificial Intelligence, guided by Shilpa R.N. Ma'am, Assistant Professor in AIML Department, GM University. So, as we know that in our world, so many medical terminologies is getting drawback day by day. So, I have choose an assignment called as an evaluate and design solutions for deploying AI in autonomous medical diagnosis systems. So, since I have done so many projects related to AI, but I have also selected because I have done a lot of projects in AI. So, I have choose medical diagnosis systems, and today I am going to explain you about one beautiful concept that is a retinal veins in our eyes. So, that is going to predict automatically when users or a doctor upload the microscopic images. So, let's start it further. Okay. So, and the team members are myself, H1BS Devang. And why AI is in medical diagnosis? Because diagnostic error are a significant burden on healthcare systems. Like 15% error rate will be there. Like so many people are not getting an accurate results while doing in a manually. So AI offers a path to faster, more accurate, and consistent disease identifications. Since we have a training a large amount of data sets in our training model, so it has an capability to predict a faster and more accurate one. So the focus is on designing deployable and responsible AI solutions specifically for image-based diagnosis. It's like we have deploying AI agentic, solutions for image-based diagnosis. Okay, this is what my suggestions to implement like this kind of things. And architecture of diagnostic AI systems, data layer like involves acquiring and preparing high quality medical data like retinal images. As I said, we have used microscopic and you know scanned images. So for good qualities or high qualities, and model layer utilizes deep learning (CNS). As we said, CNN we use it for convolutional neural network. So where the each image sectors will be divided into several layers. So each layers is going to add a new features for it to predict a good one. So and integration layer provides a diagnosis place like we are showing the risk score like how many risk is going to be in your eye. So that is what we are going to show that. So then case study retinal disease risk assessment like since there is a lot of diseases or terminologies to predict. So first is a diabetic and also hypertensive retinology, and also one is a major problem in our world is glaucoma. So where glaucoma is like a pupil problem. So when the pupil is closing up, the eye will be not seeing. Like so many people are suffering over that. So we have mainly focused on these three topics, and we are going to predict that. Then evaluating performance and impact. Like AI system demonstrate accuracy rivaling or surpassing human expert in a specific task, like greater than 90% in certain cancer detections. So many disease will be there, even cancer, cardiac arrest, or eye, everything. So but we major aim is going to predict by the retinal views. Okay, real world benefit include tragic, uh, pre-ordering urgent cases and speeding up image analysis, like 30x fastest for mammographs. Like so many people know that for manual, surgery or manual treatments, so it's take a lot of time. But in coming to AI, it's totally giving the faster retrieval, like 30x faster than the manual. So this is what the performance of our model. Okay, key ethical challenges: bias, privacy, transparency. Like algorithm biases, data privacy, and transparency. So these are the three major ethical challenges where we have come across. So algorithm biases, we have added so many algorithms to predict angles based images predictions, and also data privacy. So since there's a lot of massive amount of images will be there, so we are going to sector in a different parts, then that is going to by secured one. And transparent, the black box natures of a model, hidden as clinical trust, accountability for decisions. Like this data will be able to seen only by the doctors, so not by other patients. So there's a unique IDs for personal, patients on. So it is not going to mismatch over that. Effectiveness of a regulatory frameworks, that is, currently we have done an FDA CE marks in essential, but so many people are going to use a lot of AI deployment in these sectors. Okay, and governance must mandate, like, since it is a clinical validations, we need to take approval from the governance, right? So that is what we need to do that. Future, what is the future agentic is, since it is a powerful design to automate, not replace the expertise of a medical, exactly. So since we are coming to AI, so we are not just going to replace the expertise of a medical professional. We are just giving an opportunity for the doctors to use this tool, not going to replace as a expertise of over that. Okay, and yeah, let's go with my model. So where I have developed everything. So this is my code I have used. I am running, since I am running a Streamlit for the front end and UI index. Okay, and also I have used a CV2, that is what the layer is going to be adopted. Okay, yeah, yeah. So let's run this. Okay, okay. So now this is what I have developed, AI powered retinal disease diagnosis systems. Okay, okay. So now it is ask users to or a doctor to upload the images. Okay, we need to upload the images over here. Okay, so here you can see here there is a two or three pictures. Okay, so I will just upload one images here. After uploading, it will show the exact images, and it is no, see, you can see here it is going to analyze the results. Okay, now we can see here the uploaded image, predicted vessel, the layers one, and also it is going to add the overlay of these wings. Okay, so and also it is showing, as I said, these are three major sectors, that is a diabetic, hypertensive, and glaucoma. So this eyeball is going to be a diabetic, so it is going to mild NPDR, and also since it is a diabetic score, high biasing something, it is going to give a recommendations, and also it will show complete pixels range, and also AV ratio, width ratio, everything it is going to predict, and it shows a graph what disease you have, and also it is also giving the recommendations like mild early signs of diabetic retinopathy detected, annual eye examinations recommended. It's going to predict like this. Okay, these are the two pictures I have seen, and also I will show you another images once. Okay, now I will select this one. Okay, now it is going to analyze. Okay, see, this is also by diabetic diseases, and also it is going to vary these values. Okay, this is what my development and model prototype. So I will show you the model. Okay, this is my model. You can see here. This is my model, and I'm just going to call that model here. Okay, you can see it. So simple unit in a module, and I'm just calling that model here. Okay, see, I am just calling that model here, and based on that model, it is going to predict. Since this model is trained in the Kaggle with accessible data set, and I have just downloaded that data, and I am just assigning here. So this is what my project and a prototype related to AI have selected this topic. So this is my presentations, and thank you once again for Shilpa ma'am as a guided by me, and thank you so much. Thank you everyone.